Welcome to the Database Management System Fundamentals course. This is designed for individuals who would like to begin their journey towards learning about database concepts from basic to advanced level, covering the theoretical as well as the practical aspects. Data is important for all types of apps and websites. Data is raw, unprocessed information that exists in different forms like text, numbers, images, and videos. This data needs to be organized in such a manner that it can help us to make certain decisions. It is imperative to note that data empowers businesses to improve operations, enhance customer experience, and gain competitive advantages. It also helps in analyzing the current trends, thereby helping to strategize planning and making informed decisions. In order to store this data securely, we need a system in place. These apps are called as Database Management System. The main purpose of Database Management System is data persistence. Databases ensure the long-term storage and retrieval of data, making it readily available when needed. DBMS enforce data consistency and accuracy, preventing errors and ensuring the reliability of information. Database systems provide mechanisms to control access, protect data from unauthorized use, and ensure data confidentiality. Databases facilitate collaboration, enabling multiple users and applications to access and share data effectively. Some of the basic examples of DBMS are Microsoft Excel, Google Sheets, etc. These apps are equipped to store data securely with various types of validations and protection. However, these spreadsheet applications have certain limitations. Thus, we have more powerful and advanced systems like Microsoft Access and Microsoft SQL Server. These apps are based on relational model known as Relational Database Management System. Some of the popular examples of relational databases are MySQL, PostgreSQL, and Oracle. These systems organize data into tables with rows and columns, using structured query language for data manipulation. NoSQL stands for Not Only SQL and refers to a variety of database technologies that are designed to handle large volumes of data, diverse data types, and distributed data architectures. Unlike traditional relational databases that use structured query language and tabular data structures, NoSQL databases use different data models to store and retrieve data. They are mainly categorized into four types: document databases, key value stores, wide column stores, and graph databases. Document databases store the data in documents in such a way that's easy for humans to read and write, and easy for machines to parse and generate. Each document contains pairs of fields and values. Examples include Mongo and Couchbase. Key value databases store data as a collection of key value pairs. Each key is unique and associated with a single value. Redis and Amazon DynaMarge are the examples of key value databases. Wide column databases store data in tables, rows, and dynamic columns. Each row can have a different number of columns. Examples include Apache Cassandra and HBase. Graph databases store data in nodes, edges, and properties. They are designed to represent and query relationships between data points. Neo4j and Amazon Neptune are the examples of graph databases. When to use each one of these type of database? When you want to store the data for content management system, blogging, and applications with hierarchical data, then you must consider using document databases. Key value databases are ideal for storing the data that needs to be processed at real time, like caching or session management. Wide column databases are best for applications requiring high write and read throughput, such as time series data and recommendation engines. Graph databases are perfect for social networks, fraud detection, and network analysis. Next comes is the concept of data models. A data model is an abstract framework that organizes and standardizes how data elements relate to one another and to the properties of real-world entities. It serves as a blueprint for designing and managing data structures within a database. Some of the commonly used data models are relational model, hierarchical model, network model, and object-oriented model. Let us learn about them in detail. Relational model. This model structures data into tables with columns and rows, using relationships to link different tables. It's widely used and offers data integrity and consistency. Hierarchical model. Data is organized in a tree-like structure with a parent-child relationship. This model is suitable for structured data with clear relationships. For instance, there is a data model pertaining to university. There can be multiple data models related to this, like departments and students. Network model. Similar to the hierarchical model, but allows more flexible relationships between data entities. This model is often used in complex systems like telecommunications, transportation, inventory management, social networks, traffic management, and supply chain management. Object-oriented model. Data and operations are combined into objects, providing a more flexible and robust data representation. For example, a data model for person can be created with standard set of details like name and age. Then, using this model, other data models like student, doctor, and engineer can be created with additional entities. For retrieving data from the database, certain rules need to be followed. The language used to retrieve the data is called structured query language. This is categorized into data definition language, data manipulation language, and data control language. Data definition language is used to create, modify, and delete database objects like tables, indices, and views. Data manipulation language is used to insert new data, update the existing data, and delete data in the table. Data control language is used by database administrators to grant or restrict access to the different database objects. As per the usage, users are mainly categorized into three types: end users, app developers, and database administrators. End users are the regular users who access and retrieve data using applications, perform queries, and generate reports. App developers or software developers design and develop applications who interact with the database, implementing data access logic and security measures. On the other hand, database administrators manage the database system, ensure performance and availability, implement security policies, and back up and restore data. As mentioned earlier, securing the data is very important. Thus, certain measures need to be taken to ensure there is no security breach. First is the access control. Authentication and authorization mechanisms restrict access to data based on user roles and permissions. This ensures that unauthorized users don't get access to the database. Next is data encryption. Sensitive data is encrypted using hashing algorithms to protect it from unauthorized access or disclosure. Databases are stored on servers and they are machines. That means they are subject to outage. As a precaution, periodic backups needs to be taken to create copies of data. This smoothens the process of data recovery in case of hardware failures or data corruption.